Well, let's get going. Real quick, my name is Jim Barnes. I am the CEO of Invista. We're just right out here front. I'm going to pull the first rule that you don't actually do in consulting and really speaking is I'm going to pull what I call an AWE. You know what an AWE means? Acronym without explanation. So we have WMS acronym, WCS acronym, and WES acronym, which I just pulled off a acronym without explanation. So the next 45 minutes, I'm going to go through and explain what these are, but more importantly, what they're not, and also how they're being used in terms of deploying technology in warehouse, basically distribution centers. So who today is running a warehouse at some shape capacity, right? Hands? You're running a distribution center, right? So what I want to do is really kind of walk through this whole concept of what's happening in the market, why, and not get deep into the market, but talk about what's actually happening to define what WMS, WES, and WCS is. I'm going to kind of go through the day in the life of data and order flow because I think it's really important about how data and information moves between these systems today, which can be different systems of records and different architecture, and then walk through 3 case studies, okay? Take any questions. I've got 43 minutes to do this. There's a ton of content. I speak fast. That's probably one of my biggest problems as a speaker is I go way too fast, but I got a lot of content. So if you've got questions, you can hold them in, or if it's really bugging you, feel free to interrupt me, right? And we'll just have a conversation, right? So what's happening in the market? Look, if you're running a distribution center, running a warehouse of any shape or form, by far, labor and labor cost are probably one of your biggest issues. But not only the cost of labor, but also getting that labor and retaining that labor. Today, average load is running $60,000, if not more, but what's more important is the cost of basically replacing that labor. 2018, $7,000 to replace that labor. Now it's costing you a lot more to replace that labor when you lose that labor. So it's important that you're maintaining, right, and you're focused on retention. The second thing that's happening is most warehouses, if you run them, where does most of your actual cost, in terms of cost of goods sold, stay, right? Where is it? It's in the 4 walls of your distribution center. And so what's happening is that we're looking for ways to reduce labor, improve throughput, obviously within the 4 walls of the DC. What else is happening? Construction is slowing. Why? Because it costs more to build a distribution center from a greenfield site. Cost per square foot is going up. I remember 10 years ago, if you do the math, it's 81 cents per square foot, and that's not triple net, that's just the actual cost. 10 years ago, it was 33, 34 cents to go find distribution space. So what's happening is you as practitioners, you as leaders, are having to do more in less space or doing more in the same space. As your SKUs proliferate, as your order volume proliferates and starts to increase, you're being asked to do a lot more in less space. Fair? Makes sense? I see some heads shaking. So when we speak to chief supply chain officers, senior executives, distribution centers, CEOs, CFOs, what's keeping them up at night? We talked about hiring and retaining talent, supply chain shortages. Obviously now I don't need to tell anybody what's happening with tariffs, right? The impact that tariffs are going to have on certain commodities coming into the United States. So we're trying to do more with less, including inventory. How do I flow inventory through my network? How do I meet the demands of my customer? On the customization side, anybody in retail or direct-to-consumer business, right? How many times does your chief merchant, right, chief marketing officer come to you with a crazy idea that actually trying to drive competitive differentiation for your customer? Happens all the time, right? Hey, I got a crazy idea. Here's what I want to do in terms of improving my SLA to my customer. I want to add an extra item to the box, right? I want to do some kind of value-added service to the actual order to make myself look different. Always driving innovation, where does that buck stop? The buck stops with you to actually make that happen, right? So again, where are we seeing improvements in automation technology? A lot of it is around labor utilization. Some of it is around spatialization, but more importantly, also stock efficiency. Again, the theme is how do we do more, right, with less? It's a common theme. All right, so that's the market. Let's talk about just these applications and technologies and define them. It's hard to say, I'd be very surprised if most people here do not know what a WMS is, right? Who has warehouse management systems in their four walls? I see some hands, right? Look, I'm gonna date myself. I'm 59 years old. I put in my first WMS in 1993. You don't even know what it was called. It was called House on Engineering, okay? And I put it in 1993 for Ricoh Electronics. That was a long time ago. These applications, best of breed, have been around for a long time, okay? So we're gonna define what these are. So let's look at a warehouse management system. It's really a highly specialized supply chain business application with a purpose of flowing inventory through the four walls of your DC. I know where all orders are. I know where your inventory is. But if I'm a chief financial officer, I know the perpetual inventory cost within the four walls and the network. Main purpose. What it also is, and this is a key distinction that I want to make sure that we all understand today, a warehouse management system manages manual tasks. It is a tasking engine, okay? It is simply a tasking engine. We'll talk about planning and optimization orchestration as we move further in the presentation, but really, if you boil it down, it is a tasking engine that handles manual labor. That's what it does, okay? But it's important. So if we break it down into really the major functions, I'm handling receiving tasks. I'm handling ASN receiving. I'm handling purchase order receiving. I'm handling blind receiving. I'm handling put away. That put away can be based upon a bunch of different put away rules. Directed put away, manual put away, right? But I'm putting product away into some storage. It's handling replenishment. What does that mean? Taking product from overstock locations or storage and bringing it to a forward pick location. And all the rules around how do I do that, why do I do that, and when do I do that, right? Is it by cube? Is it by velocity? Is it by different types of rules and parameters on replenishment? I'm doing order release, okay? So I'm releasing orders into the system that I'm being fed by either my ERP or order management system, but I'm managing when I release orders, okay? Sometimes manually, sometimes through basically we also call auto scripts. Picking, all picking functionality. From a forward pick location to a replenishment location to overstock location, I'm handling the picking and packing. These are the manual tasks today that if you're running a warehouse management system, that most likely that you're doing. Fair? Okay? All right. It's also managing anything around wireless data terminals. So most likely, I hope you are not have a warehouse management system and you're picking with paper. God forbid, right? You're using voice, you're using data collection, but you're not using paper, right? Or if you're using RFID, you're using readers, right? You're using basically what we call a reader to read those RFID tags. It's also handling material handling messaging, but not controlling the material handling equipment, but just sending messages back and forth to your MHE, right? That's what a WMS is. Here's where it falls down. It falls down when there's disruption. So when you have a late truck, you have a stock shortage, you're short-staffed, you have new orders drop in, right? It's not necessarily going through the optimization and the orchestration to rerun and to manage that disruption. Now, does that mean that you don't manage the disruption? You do. But how do you do it? You do it manually, right? There's not an automatic feedback that if all of a sudden today, and I'll pick on one of my friends here who runs a very large direct-to-consumer business. Sorry, John, I'm gonna wake you up over there. If he's planning on 150 people to go into his pick module to pick eaches, and 120 show up, what does he do? How does he reallocate, right, those resources? The demand's still there, the resources didn't show up. Or if a resource, for whatever reason, is behind, how do I automatically reallocate that product, right, those picking tasks to somebody automatically? It happens manually. Does not happen today with most warehouse management systems automatically. So again, most of this is happening around manual replanning. And there's a key word here I want you to look at called on-time order fulfillment. Okay? When you think of a schedule, of any schedule in your life, what is the number of tasks or events that have to happen around a schedule? Anybody? Come on. Here we go. I have to know who's going to do the work, right? I have to know the task that's required. But the most important thing is I have to know the time by which the task is going to actually occur. Key component, time. Most warehouse management systems, right or wrong, do not have a scheduling engine built into them. They're not time-based. They're not SLA-based, service level agreement-based. They're not working backwards to actually make sure that all my resources are planned effectively and efficiently to meet that SLA. Okay? So how do you do it? You do it manually. Hey, I'm 5,000 orders short. It's 3 o'clock in the afternoon. I got to throw more labor at it, right? But it's not happening automatically. You, as operators, are making that decision, and you're making that happen. Fair? Would you agree? All right. So what's a WES? It's a software application that controls order flow within an automated fulfillment system. Key word, automated fulfillment system. Now, I will tell you that there are WSs in the market today that are also sitting on top of warehouse management systems that are doing this, but typically we see WS in terms of how work is performed, where it's being performed, and when work is being performed. Again, the when component, right, is the time-based scheduling that happens within the four walls. Okay? So today's WSs are moving away from this monolithic code base that was written by control engineers and systems integrators 15, 20 years ago. And now you're seeing on the market warehouse execution providers that are out in the space that are really truly building cloud-native microservices technology that is helping understand how work gets done, when work gets done, and who does the work, okay? So these managers that I like to refer to, you can think of them as little microservices, right? So these are things like my allocation processor is a microservice. My ASRS manager is a microservice. The way I queue messages, all these are microservices. If we're talking to a systems integrator, you're talking to a provider, and their core technology has not been built probably the last 3 or 4 years, most likely it's not built on this type of microservices architecture, which is key, okay? Why is that important? Because when you want to make changes and you want to go fast within your four walls of your DC, this core architecture is what allows you to move very, very quickly. Not going back and doing code development changes that take 2, 3, 4 weeks. I'm talking about making changes within hours, if not days, right? Key, here's what I want to make sure that you get from what a warehouse execution system is. It's orchestrating how orders are processed. Who does the work? A human or a robot? When work gets done, based upon schedules, right? Dynamically. Why is the work getting done? Because I'm goal-driven, based upon SLAs. As an example, hey, I've got a FedEx truck in direct-to-consumer that shows up at 5 o'clock. I've got to make sure that the last order processed is at 4:45. So I'm managing backwards, you follow me, to that schedule to ensure all resources are being met to meet that SLA. And I'm making changes dynamically if that SLA is going to be broken, okay? Who today, and this is probably the best metaphor, and I will use this, and again, analogies always break down over time, right? And I'm going to show you an analogy that I've used for about 7 years, and the analogy I'm going to show you is actually going to break down. Here's my new metaphor or analogy. This is what I'm talking about. Who today uses Google Maps or Apple today, right, or Way, right, to move, to provide directions? I do, right? Who does, we all use it, right? All right, so think about this analogy. The technology around what's happening between order release, routing, and managing inventory goes like this. What do I do when I want to go from point A to point B, right? They know who I am. I've logged on. I'm on my Apple phone. They know who I am, right? That's first. They know where I'm going because I put in that destination. And what does it do? It builds a route, right? It gives me a route to go from point A to point B. What else does it do? Anybody? Gives me a time estimate of how long it's going to take me to get there. What is that? That's a schedule, okay? So as I'm moving down the road, there's a traffic jam. Let's put it in our world. That's called a what? A constraint. Something happened that was non-scheduled. That is a constraint. Now, here's where the magic happens. Do I go replan my route? Do you replan your route if there's a traffic jam or you're slowing, right? Do you replan? No. Apple replans that route automatically. Now, you can accept it or not. In case of my car, when it replans, it actually calls my wife because it's tied to my calendar and it says, hey, JJ, Jim's ETA is now changed. I don't do that. The car does it with my phone, fully integrated. See the metaphor? See the analogy? That's the future of where warehouse execution software is going, okay? So I won't bore you with all the different functionality, but you can see orders, containers, routing, inventory is really what warehouse execution systems are starting to do. All right, let's give an example. So if you're looking at a front view, and this is a GTP shuttle, and I don't care what it is. If it's Geek Plus, Quicktron, Gray Orange, Savoie, it doesn't really matter. It doesn't really matter what it is. The difference is what the warehouse execution system is doing is it knows where the inventory is within the actual GTP. So I've got SKU, tote ID, and quantity. And it's managing the sequence, right, in the order flow within that GTP system. The warehouse management system is not doing that. Your warehouse management system knows what the inventory is in aggregate, right? But it has no idea what's inside each of these totes. Nor is it going to manage the actual robot to pull that tote out. That's all happening within the warehouse execution layer, okay? So just a simple example of where warehouse execution systems fall versus a WMS. Make sense? Right? All right. WCS. Before there was warehouse execution, and I'm going to date myself, 20, 25 years, we built what was called a warehouse control software. Now, what does a WCS do? Any electrical engineers here? Any double E's? Any control engineers? Okay? So today, right or wrong, when we go do a distribution automation project, and I've got to talk to a machine, and when I say talk to a machine, talk to an industrial robot, Allen Bradley, a Siemens type, right? What do? We write, for those who don't know, we write what is called ladder logic. The computer technology or the industrial computer company like Siemens or Allen Bradley, we take their software, we write ladder logic to actually do Boolean logic, if-then. Where do those if-then conditions come from? Well, when I see a barcode and I scan it, where does it go? But if I want to make a change, I don't need electrical engineers or control engineers to make those changes. I go into this layer called a WCS that sits on top of it to make those changes to my automation. Make sense? So I don't need a double E to go rewrite ladder logic. I use the WCS layer to go make those changes. So if I see an emergency stop and I want to go do something about it, I see a fault condition, I don't go to the PLC level. I go to the WCS, and it will actually communicate now with the actual industrial computer, right? All right. So let's talk about, because sometimes it's easier to talk about what systems are not. So warehouse management system is not going to interface with your PLCs. That's what a WCS does, right? It's not going to directly interface with input and output devices. It has no idea about things like scanners and inline scales and cameras, okay? Does not communicate with those types of field devices. It does not manage your put to light if you have a put to light type system, okay? It's not going to track, keyword, it's not going to track carton level LPNs, license plate numbers, or RFIDs on your mechanization. Doesn't do it. It's at a very, very high level, okay? It's not going to provide a GUI, AutoCAD layout of your automation system, and it's not going to dynamically allocate orders real time and do replenishment across automated facilities. It'll do it manually, but it's not going to do it dynamically, right? All right, what's warehouse execution not? Well, most, not all. It's not going to manage all inventory locations within the four walls. It may manage the inventory within certain automation pieces of equipment, but it may not manage every single location within the four walls. So it's not your perpetual inventory system of record that's going back to your ERP with your financials, okay? What's a warehouse control system? Just a couple bullet points here. It's not going to interface directly to any kind of ERP or order management. I mean, there are always exceptions, and there's always exceptions to these rules. So this isn't like, oh, walk away from this presentation and it's binary 0, 1. There's always some overlap, okay? But it's not going to support the management of what's happening. It's not going to manage the orchestration of your orders. It's not going to manage the hard allocation and the soft allocation of inventory. It's really there to support you at the machine control level in an automated facility. My metaphor. I've used this metaphor for about 7, 8 years. This metaphor, I throw it up here, but it's starting to break down. Where I would say, traditionally, your warehouse management system have been the brains. Your warehouse execution has been your central nervous system. And all these different types of physical machines or robots are ultimately your bones, right? And then your WCS and PLC are your senses. I'm looking for inputs and outputs. I'm giving it back to the actual WES. It's reprocessing, right, based upon the brain, which is your WMS. Those lines are starting to blur. They're starting to blur, okay? So what you're starting to see is that warehouse management systems who have actually typically worked in batch mode, I've got work, I batch it through what we call, what? Waves. Anybody here not hear the term wave, right? Probably the most used verb, right, that you use in warehouse. I've got to go wave the orders, guys. Who's running waves? I'm running the waves. Have you released the wave yet? No, I'm not released the wave yet. What are waves? Waves are nothing more than running batches of work. It's a military term, for those who don't know. That's where the origin of waves came from. Taking resources, waving them together to meet an outcome. It's a military term. We like to think that we actually created the word wave. We did not. It's a military term, right? But the lines are being blurred between what a warehouse management system is and what a warehouse execution system is. So things on the left, ERP integrations, advanced receiving, reverse putaways, maybe doing even RMAs in terms of reverse logistics, definitely sit on that left-hand side with WMS. But in the middle, the things that you do every day, picking, shipping, replenishment, tasking, orchestration are all starting to blur these lines, right? The key takeaway is that historically, warehouse management systems have been really thought of as more historical batch wave thinking, where WSs are really focusing on automated decision making, real time, what's happening across all my subsystems, across all my agents. I use the word agent because you'll hear the term probably a lot around the whole concept of multi-agent orchestration, right? It's a new term, new buzzword where I've got multiple robots today working in my DC, and I'm agnostic. So it's multi-agent orchestration. So you're starting to see some blurring between these two applications. And then on the WCS, right, it's handling things like my machine control, handling things like my print and apply. Why? Because you notice on the right-hand side, I need speed. I'm not talking about seconds. I'm talking about milliseconds. 80-second, 200 millisecond response time. When I have an input, I need an output. When I'm moving cases at 200, 300 cases per minute, I need really, really, really fast connection between the WCS and the actual industrial computer. Fast, right? All right. Day in the life order flow. I'm going to spend a little bit of time here, but I want to spend a lot of time on some use cases. So I've been doing this for 31 years. Standard interface diagram, right? Between an ERP, host, or order management, and a WMS or WES. I don't care. Every interface you do, every interface diagram, I'm going to have POs, I got detail receipts, I got an item master, sales orders, shipment detail, and inventory adjustments. That's your flow, right? It doesn't change a lot. Day in the life pre-WES. ERP or order management gives me orders. They soft allocate to make sure the actual inventory is in the building. Warehouse management system takes those orders, does a her allocation, and says, go perform the work, right? Not how work gets done, but what and why, and when do I actually need it, okay? Typical day in the life order flow. I'm not going to bore you too much with this, but and this will be in the presentation if you want it. But if you want to look at really how data moves back and forth between the systems, this just gives you kind of an idea of how data moves between a WMS to a WCS, right? And you can see, quite frankly, carton is scanned, scanner sends to a PLC, PLC sends the WCS. Again, you won't read it verbatim, but there's a lot of data moving back and forth between these applications. Why do I put up this? Anybody know what this is? Right? So if you've ever designed a building, you've ever designed an automated facility, you've ever designed a control panel, this is simply an electrical schematic of when and how I've got to actually run devices to each motor, right? So any EEs or controls engineers, I hope you geek out on this. Why I show this is that this is going to be taken by a controls engineer who's going to go write that ladder logic to make sure those motors turn on in the right sequence, right? So if I see a stop, what do I do? If I see a full read location on a scanner, what do I do? That's why I show this, okay? So starting at the bottom level to really the brains. And then instead of giving you all that digibabble, we today can show this graphically. So there's just a rendering of a conveyor with an induct, and I can show you all the actual field devices, and if a field device or something happens real time, I know what's happening. I can see it real time, right? Anybody have this in their DCs today? You can go see what's happening real time? Nope, right? All right. I won't bore you with this, but this is just a level of detail we get into with SCADA, like when there are fault conditions, what's happening, right? All right, day in the life of orders with the WS and WCS. Very similar structure. The difference is I may hard allocate with a WMS, But the WES now is taking over, and now it's managing and orchestrating the orders, right, lines or SKUs and units across these subsystems or right to the robotic control layer. So it's now speaking to the subsystems, and it's orchestrating the events, the timing of these events or tasks across these types of subsystems. So I don't care if it's an AGV, I don't care if it's conveyor and a sorter, cross belt, tilt tray, Bombay, I don't really care. ASRS or GTP, good to person system, since Jim doesn't like to use Oz anymore, GTP meaning good to person, and an AMR, right? So it's managing how and when work gets done across these agents. Make sense? All right, some case studies, and I got 14 minutes. Great example. Where does this technology apply within your four walls? Where do you apply each piece of technology within the four walls of your DC? So this is you can see it by the drawing. Very straight, single deep, and some double deep pallet reserve. We're doing primarily full case pick to pallet, and also some simple cart picking out of racking. Not that complicated. No automation. The way that work gets done is it's being done by humans, right? Okay? So in this particular situation, the client's like, look, our WMS is long in the tooth. It's not end of life, but we want to get more out of it. We think that we've got to get more out of the building by managing how we actually manage our replenishment task and managing our picking task. But we know we've got a challenge because we're working in this batch environment. We want to move away from batch or waves, and we want to move to this whole concept called waveless, right? Orders drop, and I just process the work. Let the machine, let the algorithm figure out when to release the work based upon what? What resources do I have? How much capacity do I have? And the throughput, but more importantly, when does work need to get done? So what we did is we said, look, why go spend $2.5 million ripping out your WMS? We know it's 10 years old, right? You can't really justify it. Why don't we just put a WS layer on top of it to manage the order orchestration flow and just relegate the WMS to a tasking engine? We did this with a company here called Logistic View. You're looking at about a 22% improvement in throughput, simply because it took its AI engine, evaluated how work gets done, looking at the throughput, and it made real-time decisions on processing the work. Why? What did I say before? The warehouse management system wasn't really scheduling the work. It was just saying, get the work done. It wasn't really managing how work got done, right? So that's where the WS came in and really improved the throughput of this manual facility. All right. So how does that happen? So here's a good graphic. It's one of my favorites. Traditional warehouse management systems, and not all, I will tell you that there's a lot of tier 1 providers that are here at ProMat that are figuring this out. They know to keep up in these automated facilities, they have to make changes to their warehouse management systems that move from this queue-based tasking, right, type decision-making to more of an orchestration engine that's either running some form of machine learning that says, just give me the orders. I know the capacity, I know the throughput, I know what resources. I will release work based upon when work needs to get done to meet an SLA. I'll determine if I batch or run discrete based upon where I'm at in the day. Make sense? I'll give you a good example. If I've seen the order profile for this particular client many, many, many times, right? I'm going to let the machine learning understand what those order profiles look like. Maybe from 7 a.m. to 2 p.m., I'm working in batch. Why? Because I have time. My SLA is at 5 o'clock. At 4:30, I can't work in batch. I got to go from being efficient to being effective. See the difference? So the way I actually release work and how work gets done will change dynamically through the day. You follow me? Right? So that's what's happening today as we meet to orchestrate how work gets done. All right. Real quick, if you want to see what this looks like from a visual perspective, WES decision support and performance variability, I call it visibility. So as work gets done, I can see who's doing, in this example, each task. I know how long it's being taken, and I'm either going to reassign that work to a new associate, I can do it manually, or I can let the application do it automatically, right? Now, here's what's getting interesting with respect to RFID tags. We're now starting to put RFID tags in your badge, so I know where you are. Almost like a GPS, right? And so now I can reassign work based upon where you are physically in the building, dynamically, right? Pretty cool. Case study 2. WMS, WCS, and PLCs, no warehouse execution. Pretty picture, right? Facility that we actually designed for a shoe wholesaler and retailer. But there's really no automation in this business, in this particular site, with the exception of the conveyance and the pick-to-light. We allowed, right or wrong, the WMS to manage most of the actual picking assignments. I didn't need, at the time, a warehouse execution software to manage it. Hindsight's 2020. This was about 7 years ago. But at this particular time, we didn't use the WES. We just used the WCS to manage the machine control of the conveyor, the inline scales, the dimensioners, right? The pick-to-light, put-to-light systems in this particular design. So again, it just depends. Now, let's look at this one. Much more complicated, right? 1.3 million square foot facility doing house goods, e-com, processing 100,000 orders a day. Okay, a day, 100,000 orders a day at peak. GTP systems in the middle, value-added services that are automated value-added services at top, big storage area. So in this case here, we use the warehouse management system, but we relegated it to really 3 functions: inbound receiving, pallet build, and put away. That's all it did. The warehouse execution system manages today everything else. So when orders drop, the orchestration of what happens, when the replenishment tasks are required to fill the GTP, when we decant, how we decant, how much we decant. When I say decant, you guys know what that means, right? Broken case decanting. Take a broken case, I take 3, put it in one tote, put another 2. That's what we mean by decanting. All that happened with the WS. All the packing screens, all WS, all the routing, right? Warehouse execution system. So again, the entire facility, the brains and the orchestration was happening with the warehouse execution software, not the WMS. Okay? Again, just other visibility for total system performance. So everything on that system is being measured. When we make a reallocation change, why do we make a reallocation change? I thought I could pick it out of the GTP. I was behind. I had to send somebody to go pick it manually out of forward pick, happening dynamically. Nobody's looking at it. It's just doing it dynamically, right? All right. Here's the future. WMS plus WES plus WCS will become a warehouse optimization system, or was. Now, you could change out optimization with orchestration, but the future today is going to be around warehouse optimization or warehouse orchestration systems. What does it include? There will be a labor management component to it. Because not every facility that you operate is going to be lights out with automation and robots. I mean, we're close, but we're not there, right? Every one of these systems will have a planning and scheduling engine. They'll go through an orchestration execution engine that will be based on machine learning, okay? There'll be analytics and visibility as to what the decisions were made and why they were made. So it's just not a black box. It's important to understand why the decision was made. There'll be the machine learning and AI component to it today. And then the ability to manage, again, multi-agent orchestration will also be there to manage those resources. Either communicating to, and if you're not familiar with this term, every robotic company out here today has what we call an RCS, right? RCS stands for Robotic Control Software. The robotic control software is really what's managing the routing and the logic to move the iBots, right? Then that RCS communicates right to the firmware, right, the I/O to the actual iBot. That's how it works. So you can either have a WS that actually speaks to the firmware, and that provider has actually been certified on the WES, or you can speak to the robotic control software, what I call it less black box, but more white box. Make sense? Different ways to do it. But ultimately, the WES will speak right to the robotics and automation equipment, right? All right. Lessons learned, and I've got 3 minutes. I'm right on time. Understand, where does these applications fit within your organization? When designing a new building or retrofitting a new building, where does WMS versus warehouse execution versus warehouse control system fit within the four walls of your building? And the lines are getting much more blurred. The technology that, when I spoke 2 years ago at ProMat or spoke last year at Modex, just in the last 12 months, the functionality across these applications are starting to become blurred very, very quick, right? Understand, this is key, understand how the physical movement of inventory, unit of measure, moves through your facility so you know how to optimize your order routing to meet your SLAs. And when I say unit of measure, each interpack, case, pallet, right? Those are units of measure. How do you move inventory to meet your SLAs, right? Is your DC manual or automated? Will help you guide your decision. If I'm completely manual, I'm probably going to need a warehouse management system. A warehouse control software is not going to manage your operation, right? Use a solution architect. This is key. This technology and what's happening and the pace by which we're moving, I'd be a betting man to sit there and say most people can have this level of deep discussion with you because it's moving at such a fast pace. If you don't have a solution architect that understands how this all works, find one, right? How does the mechanical side, the robotic side, the enabling technology, the integration, the data analytics, the machine control, how does it work all together to get you to the outcome that you're looking for? That was a lot in 45 minutes, and I've got 45 seconds left. So thank you for your attention. I appreciate the nod shakes, right? The smiles, the nonverbal communication. I hopefully this resonates. If you have any questions, you can reach out to us or just contact me. Thank you.